You are living in an age where the cosmos has suddenly begun to speak to you in whispers, and each whisper carries a mystery so vast it shakes your understanding of what the universe truly is. For most of human history, the sky has been a backdrop, distant, silent, unreachable. Stars twinkled, planets wandered, comets flared across the night in brief and fiery arcs, but they all belonged here to the family of the solar system. You told yourself a story of belonging, of familiarity, of boundaries that could be trusted. The sun was your anchor, the planets your siblings, the comets and asteroids your extended kin. Everything felt local, everything felt known. And then in 2017, something arrived that broke that story. It was called Oumuamua, a Hawaiian name meaning a scout, a messenger from afar arriving first. The name was chosen with care because that object wasn't part of the solar system at all. It had come from somewhere else. Out there, across the interstellar void, traveling for millions of years before brushing past the sun and shooting away again. You were witnessing the first confirmed interstellar object ever detected by humanity. Oumuamua didn't look like anything you expected. It wasn't round like most asteroids. It wasn't fluffy and gaseous like a comet. It was long, thin, cigar-shaped, or maybe flat like a pancake, depending on how it tumbled. It didn't shine with the glow of an icy tail. Instead, it accelerated, ever so slightly, as though pushed by some hidden force. Scientists scrambled to explain it. Was it a hydrogen iceberg sublimating in ways never before seen? Was it a shard of a shattered planet ejected from a distant star system? Or, though many resisted the thought, was it something else entirely? Could it have been artificial, perhaps a fragment of alien technology, a discarded probe, or even a sail driven by starlight? You remember how the debate electrified the world. Overnight, astronomy left the quiet shadows of academic journals and filled newspapers, podcasts, and late-night conversations. The question felt too large to ignore. If this was a messenger, what message did it carry? If it was natural, then it was a clue to the processes of alien solar systems. If it was artificial, then you were no longer alone. Oumuamua slipped away quickly, too small and too fast to chase, leaving only questions in its wake. But that wasn't the end of the story. It was only the beginning. Because now, only a few years later, you find yourself staring at the skies again, hearing another whisper, seeing another visitor. It carries a different name, 31 Atlas. At first, it may seem just another catalog entry, another icy wanderer named for the Atlas Survey Telescope in Hawaii. But buried in that name is something remarkable. 31 Atlas is not bound by the sun's leash. It too is coming from the deep dark between the stars. It too may be interstellar. And so you ask yourself with excitement and unease, is this the next Oumuamua? When astronomers first tracked its path, they noticed its orbit was strange. The trajectory did not curve like that of a normal comet, born in the Oort cloud or the Kuiper belt. Instead, it appeared hyperbolic, open, unbound. That single curve suggested a story as vast as light years. This was a traveler from far away, not a child of your solar system, but a visitor. Unlike Oumuamua, 31 Atlas was recognized much earlier in its journey, while it was still inbound, heading toward the heart of your planetary system. That gives you a chance, perhaps for the first time in history, to study an interstellar object in detail before it slips away forever. Think of that. For thousands of years, your species has looked up, wondering what lies beyond. Then, suddenly, in the span of one human lifetime, not one but two interstellar wanderers have crossed your doorstep. What are the odds? What cosmic story is unfolding? Could it be that the galaxy is teeming with such fragments, messengers constantly drifting, and you are only now learning how to notice them? Already the comparisons have begun. Like Oumuamua, 31 Atlas seems to be no ordinary rock. Its brightness fluctuates. Its trajectory hints at forces beyond simple gravity. Yet it also has the faint shimmer of a comet, perhaps some gases venting, perhaps a halo of ice vaporizing as it nears the sun. But is that really what it is? Or is there something about this visitor that doesn't fit the patterns, that forces you to ask questions you are not yet ready to answer? Astronomers have turned their eyes, their telescopes, their computers toward it. They are calculating, simulating, testing. Each new data point is like a clue in a vast detective story, and you, as the listener, are pulled into that mystery. You cannot look away. For in this object lies the potential to reshape how you see the universe and how you see yourself. Imagine the perspective. You are standing on a small planet, circling a medium star, and through the darkness comes a piece of another system, perhaps shattered long ago, perhaps ejected during the birth of alien planets, perhaps carrying within it the mineral fingerprints of a world unlike any you've known. Or, if the boldest ideas hold even a grain of truth, perhaps this is something built, a relic of intelligence that does not call Earth home. Your heartbeat quickens as you realize this is not just astronomy. This is contact. Not with life, perhaps, but with the wider galaxy. A reminder that your solar system is not a sealed bubble. The boundaries you once trusted are porous. Material crosses the void. The universe is connected. And so you begin this journey to explore what Oumuamua was, what 31 Atlas might be, what scientists argue, what mysteries remain unsolved, and what it means for you as a human being adrift in the great cosmic ocean. This is the story of the next interstellar mystery. This is the story of whether 31 Atlas is the new Oumuamua, or something stranger still. You remember the moment it began. It was October 2017, just another night of sky surveys, when astronomers at the Haleakala Observatory in Hawaii spotted something faint and fast moving across the background of stars. At first glance, it looked like an asteroid. Nothing unusual in a solar system littered with rocky debris. But when orbital calculations were run, the numbers refused to cooperate. The object's speed was too high, its path too wide. It wasn't looping back toward the sun. It was slicing through the solar system on a trajectory that meant only one thing. It had not been born here. The announcement spread like wildfire. Humanity had detected its first interstellar visitor. At last, the sky had given you proof that pieces of other star systems do indeed cross your path, drifting for millions, even billions of years, until chance brings them into your neighborhood. Oumuamua was officially designated 1I 2017 U1, the one eye standing for the very first interstellar object ever recorded. That alone would have been historic. But the more scientists looked, the stranger the story became. At first, they assumed it was a comet. After all, comets are icy wanderers, and ice sublimating into vapor could explain its subtle motion. But comets glow, leaving long, dramatic tails, even faint ones, when they near the sun. Oumuamua had no tail, no coma, nothing that betrayed the behavior of a comet. It was silent, dark, and oddly clean. So maybe it was an asteroid, a fragment of rock or metal, but asteroids typically follow stable paths. Oumuamua didn't. Its velocity was far higher than anything bound to the sun. More unsettling was what happened next. It accelerated, not dramatically, not with the sudden force of an engine, but with a gentle push that could not be explained by gravity alone. The sun's pull should have slowed it down predictably. Instead, it gained speed as if nudged by an invisible hand. Astronomers scratched their heads. They tried every natural explanation. Could it be a block of pure hydrogen ice, evaporating in a way no one had ever observed? Could it be a splinter of nitrogen ice, chipped from a Pluto-like planet around some distant star? Each theory seemed plausible at first, but each ran into problems. The physics didn't quite match. The brightness didn't align. The shape, so elongated, so extreme, was unlike anything in the solar system. Some studies suggested it was 10 times longer than it was wide, like a cosmic cigar. Others suggested it might be a flat, thin sheet, tumbling through space like a leaf in the wind. Then came the boldest hypothesis. What if it wasn't natural at all? Avi Loeb, a Harvard astronomer, made headlines when he suggested Oumuamua could be a fragment of alien technology. Perhaps a light sail, a paper-thin craft propelled not by rockets, but by radiation pressure from starlight. It explained the acceleration without a visible tail. It accounted for the odd shape. It matched the strange reflectivity of its surface. The idea was dismissed by many as far-fetched, even sensationalist. Yet it lingered because no natural model fully explained what was seen. And that's where you find yourself caught in the tension between the familiar and the unknown. On one hand, Oumuamua could simply be an exotic shard of rock or ice, a reminder that other star systems produce debris unlike anything you've cataloged so far. On the other, it could be evidence, indirect, subtle, but tantalizing, that you are not the first intelligence to send something across the stars. What makes the story bittersweet is how fleeting it was. Oumuamua was discovered only after it had already passed closest to the sun. By the time telescopes pointed, it was dimming rapidly, already on its way out. There was no time to send a probe, no time to chase it down, no time to gather more than the faintest of glimpses. It came, it puzzled you, and it left, vanishing into the dark like a secret that would never be told. And yet, its legacy endures. It taught you that the galaxy is not static. It showed that interstellar debris does cross paths with your world. It reminded you that discovery often comes with more questions than answers. Most of all, it set the stage for what comes next. Because when the next interstellar object appeared, scientists would be ready, or at least they would try to be. And so, as you stand at this new threshold, staring at the approaching mystery of 31 Atlas, you cannot help but carry the ghost of Oumuamua with you. Its silence, its strangeness, its refusal to fit inside neat categories, all of that shapes the lens through which you now look at this new visitor. You ask, will 31 Atlas behave the same way? Will it confound every theory? Or will it finally reveal the answers that Oumuamua refused to give? You are no longer a spectator. You are part of a species waiting, watching, hoping not to miss the second chance the cosmos has offered. This is where the mystery deepens. It begins quietly, as these things often do, not with fireworks in the sky or the sudden burst of a comet's tail, but with faint streaks of light across a digital image. In late 2024, astronomers working with the Asteroid Terrestrial Impact Last Alert System, ATLAS, survey in Hawaii noticed an object sliding across the stars. At first, it seemed ordinary, just another entry in the endless parade of small bodies cataloged nightly. A new comet, perhaps, one of thousands. Its official name became 31 Atlas, a designation as dry and forgettable as any in astronomy. But almost immediately, the numbers began to whisper a different story. When orbital elements were calculated, something strange emerged. The path was not elliptical, the way planets, asteroids, and most comets curve around the sun. It wasn't even parabolic, a long, slow arc that stretches outward but still feels the sun's touch. Instead, it was hyperbolic, a path that cuts through the solar system once and never returns. That single fact changed everything. Hyperbolic means unbound. Hyperbolic means a traveler from far beyond. Hyperbolic means interstellar. The excitement spread. Had humanity just discovered another Oumuamua? This time, though, the circumstances were different. Unlike in 2017, when Oumuamua was first noticed only after it had already swung past the sun, 31 Atlas was caught on its way inbound. It was still approaching the inner solar system. That meant there would be time, precious months, maybe even years, to study it before it slipped back into the abyss. Telescopes around the world turned toward it. Observatories in Chile, Spain, and Hawaii gathered light curves, analyzing how its brightness rose and fell as it rotated. Radio astronomers debated whether to listen for signals, just in case. The European Space Agency and NASA began discussing what, in theory, a rapid response mission might look like. Could a spacecraft be launched in time to intercept it? Could this be the opportunity that Oumuamua had denied? You can feel the shift in tone. What began as a faint speck of light is suddenly a cosmic event, a once-in-a-lifetime encounter. And the more data comes in, the more intriguing it becomes. Unlike Oumuamua, which remains strangely dry and tailless, 31 Atlas shows faint hints of activity. A subtle coma surrounds it, a hazy atmosphere of gas, likely water or carbon compounds sublimating from its surface. That detail makes it behave more like a comet than a rock. Yet its orbit insists it is something far stranger than any comet in your solar system. It came from elsewhere. It carries with it the fingerprints of another star system. And so the comparisons begin in earnest. Oumuamua was enigmatic, silent, fast, and frustratingly elusive. 31 Atlas, by contrast, is louder, more visibly active, more cooperative. If Oumuamua was a locked box that you never had time to open, then perhaps this new object is a book you can finally read. But as always, the universe resists simplicity. The very activity that makes 31 Atlas easier to study also complicates the story. Gas jets, vapor plumes, sublimation, they can alter an object's motion in ways that mimic the mysterious acceleration seen in Oumuamua. Is 31 Atlas accelerating under some exotic mechanism, or is it simply behaving like a comet ought to? Is it special or ordinary? Is it natural, or does it carry whispers of the artificial once more? As you watch astronomers debate, you realize that the heart of the mystery is not just scientific, it is emotional. Humanity wants answers. You want clarity. But interstellar visitors rarely offer clean truths. They arrive on their own terms, and you must learn to read their language. Already, the story of 31 Atlas is shaping into something profound. For the first time in history, you have the chance to study an interstellar object while it is still inbound before it makes its closest approach to the sun. That means more time to watch, more data to gather, more opportunities to test every theory. It also means more time to wonder, because every new observation seems to raise fresh questions. What is its true shape? Elongated like Oumuamua? Flattened like a disk? Or something more irregular, a fragment of a shattered world? How volatile are its ices? Do they match the chemistry of comets in your solar system, or do they carry signatures utterly alien, proof that it was forged under a different star's light? How long has it been drifting through the galaxy? Millions of years, or billions? Did it pass close to other stars before it found its way here? And deeper still, if Oumuamua sparked whispers of technology, should you ask the same of 31 Atlas? Or does its faint cometary glow place it firmly in the natural category, a relief to those who prefer simple answers, a disappointment to those who yearn for proof of other minds? You don't know yet. No one does. But that uncertainty is the gift of the cosmos. Each time you glimpse one of these interstellar wanderers, you are reminded of how young your science still is, how small your data, how vast your ignorance. And that is not defeat, it is wonder. For now, 31 Atlas is inbound, still months away from its closest brush with the sun. The telescopes are waiting, the debates are heating, and the shadow of Oumuamua looms large, demanding comparisons at every turn. The question echoes in your mind: is this the next Oumuamua or something entirely different? You are about to find out. When you first hear that 31 Atlas follows a hyperbolic trajectory, it might sound like just another mathematical detail, a dry note scribbled in the logbooks of astronomers. But to understand it is to glimpse the vastness of space in motion. It is to realize that this little speck of ice and dust has traveled not from your solar system, but from far, far beyond. Let's pause for a moment and picture the difference. Imagine standing at the center of a great spinning dance hall. Around you, planets glide in perfect ellipses, bound by the music of gravity. Each comet, each asteroid, each object that belongs to the solar system traces a closed loop, long or short, eccentric or circular, but always returning, always tethered. That's the family dance of your sun. Now imagine someone opening a door at the far edge of the hall and a stranger walks. They don't move in circles. They don't return to the rhythm. They stride straight across the floor, cutting between dancers, and exit on the opposite side, never to be seen again. That is what a hyperbolic orbit looks like. It is the unmistakable signature of an interstellar visitor. For 31 Atlas, the numbers tell the tale. Its eccentricity, the measure of how stretched an orbit is, was calculated at greater than 1. Anything less than 1 means bound. Anything equal to 1 means parabolic, balanced on the knife edge. Anything greater than 1 means unbound, open, infinite. And 31 Atlas sits firmly in that realm. It is not the child of the Oort cloud, not a comet tugged loose from your sun's icy frontier. It is a drifter from another system, perhaps thrown outward during the birth of alien planets, or stripped away when stars dance too close to one another. Think about the journey it has taken. To reach you now, it may have traveled for millions of years, even billions. It may have passed within light years of other suns, grazing the edges of other planetary families, before your sun's gravity finally pulled it close enough to notice. Its path is like a scar across the galaxy, a record of violence and chance stretching across unfathomable time. What makes 31 Atlas so remarkable is that you are catching it before it passes through. Oumuamua was already outbound, already escaping when you realized what it was. But this time, the story is different. The inbound arc offers time to predict, to prepare, to study. Astronomers can calculate precisely how close it will pass to the sun, how bright it might become, how its gases may flare as heat wakes the ices on its surface. It's as if the universe has given you advance notice of a guest's arrival, a chance to tidy the room before they knock. And yet, the trajectory does more than tell you where it's going. It hints at where it came from. By projecting its orbit backward, scientists can attempt to trace its origin. Which region of the galaxy did it drift out of? Did it come from a known stellar nursery, a region thick with young stars and planets forming? Or did it escape from an old, stable system, flung out by gravitational interactions with giant worlds? Already, computer simulations are running, feeding on the scant data you have. Each possibility branches into others. If the backward path intersects with known stars in the recent past, perhaps you can identify its parent home. If not, then it may have been drifting so long that all memory of its birthplace is lost, its past swallowed by the slow shuffle of galactic motion. But one thing is certain, it does not belong to you. It does not belong to the sun. And that realization, more than anything, gives it weight, because in the quiet truth of orbital mechanics lies a profound emotional shock. The walls of your solar system are not walls at all. They are porous, open. Matter slips in and out. Visitors can arrive without invitation. The universe is not a locked room, it is a highway, and you are one stop along the way. As 31 Atlas arcs inward, its trajectory also carries a practical gift. A hyperbolic orbit means it is on a one-way trip, a fleeting encounter. But it also means that the laws of motion are predictable. Astronomers can chart exactly how fast it will move, how close it will pass, how long it will remain within reach of your best telescopes. That certainty lets scientists plan campaigns of observation, coordinate instruments across the globe, and squeeze every last photon of information from the encounter. You find yourself imagining what it would feel like to ride along with it. To drift on that ancient path, feeling no sun's warmth for millions of years, then suddenly plunging into the light of a new star, your surface boiling, venting, crackling with energy. To you, it is data. To the object, it is destiny. And in that destiny lies another question. What happens after it leaves? Once it slingshots past the sun, it will head outward again into the same dark abyss it came from. Will it wander endlessly until captured or destroyed? Or will it drift close to another star, centuries or millennia from now, to become someone else's first interstellar mystery? That is the poetry of a hyperbolic path. It connects not just systems, but civilizations. For all you know, in the distant future, another world may puzzle over 31 Atlas the way you puzzle over Oumuamua. To them, you will be the strangers. For now, though, it is your turn to watch. Its path has brought it to your skies, your telescopes, your moment in history. Its orbit is the message, and the message is clear. You are not alone in the galaxy's flow of debris. Visitors will come again and again. The question is whether you are ready to listen. Section 5, A Shape in the Darkness. When you look up at the night sky, you imagine these objects as solid, tangible things, rocks, ice, dust. But in truth, they are only ever points of light in a telescope, faint signals smeared across the CCD sensors of observatories. To see them, you must translate flickering photons into meaning. And so when you ask, what does 31 Atlas look like? The answer is not simple. It is a puzzle pieced together from shadows. Astronomers measure its brightness curve, the way its light rises and falls as it rotates. That curve is like a heartbeat. Each peak and valley hints at its shape. If the light fluctuates sharply, it suggests elongation, a body stretched like a spindle that flashes brighter when its long side faces you and dimmer when it turns away. If the curve is gentler, the object may be more rounded, more familiar. Early observations of 31 Atlas suggest it may be irregular, perhaps elongated, perhaps not as extreme as Oumuamua, but certainly not spherical. Its rotation is uneven, tumbling chaotically rather than spinning neatly around a single axis. That chaos is telling. It suggests that this fragment was once struck, broken, unsettled by some ancient collision. Like a scarred traveler, it carries the memory of violence in its wobble. And then comes the question of surface composition. The color of its reflected light reveals subtle clues. Reddish, like objects in the outer solar system, baked and darkened by cosmic rays, or brighter, grayer, coated in fresh ices recently exposed. Observations show a faint reddish hue, a tint often seen in long drifting bodies exposed to interstellar radiation. It is the color of time itself, written across its skin. But here is where comparison becomes irresistible. You remember Oumuamua, how its shape defied expectations, how some studies suggested a 10-to-1 elongation, unlike any asteroid or comet seen before, a cigar or a pancake, tumbling and glinting, reflecting sunlight in ways that made it impossible to model cleanly. Oumuamua's geometry was part of its enigma. By contrast, 31 Atlas seems slightly less alien. Its coma, that faint, fuzzy halo of gas, softens its outline. It looks more like a comet, less like a manufactured shard. Yet it is still different enough to provoke curiosity. Its surface may not be smooth. It may be jagged, riddled with cracks where heat prees ices into vapor. Each jet of gas could shift its spin, alter its path, make it behave unpredictably. Astronomers attempt to simulate what it might look like up close. Imagine a lumpy, potato-shaped nucleus, a few hundred meters across, with cliffs of ice crumbling into dust. Imagine jets venting from fractures, spraying particles that glisten briefly before vanishing into the void. Imagine the reddish skin of interstellar radiation, scarred by the journey, punctuated by brighter patches where fresher ice peeks through. This is not a polished jewel. It is a survivor. And yet, in the back of your mind, you cannot resist asking the forbidden question. What if the shape is not natural at all? If Oumuamua tempted you with that thought, why not 31 Atlas as well? A tumbling shard could be a fragment of technology. A thin, flat geometry could be a sail. A hollow form could be a shell. The human mind cannot help but see pattern, design, intention, even when nature alone may suffice. Here lies the tension between science and imagination. Scientists work carefully, resisting leaps to the extraordinary. They remind you that comets are strange, that collisions create shards, that interstellar journeys redden and reshape. The irregularities of 31 Atlas can all be explained by natural processes, and yet, outside the strict walls of peer review, speculation thrives. Each new wobble in the light curve fuels whispers. Could this, like Oumuamua, be something more than ice and dust? The truth may never satisfy your hunger. Even if telescopes capture every possible data point, you will never see it clearly with your own eyes. Unless a spacecraft intercepts it, and that is a dream more than a plan, you will always be squinting through distance, filling gaps with imagination. But perhaps that is the gift. The shape of 31 Atlas is not just physical, it is symbolic. It is a mirror for your curiosity. In its irregular rotation, you see the scars of creation. In its faint glow, you see the fingerprints of alien suns. In its tumble, you see the chaos of the universe itself. And so the object remains both known and unknown. You can describe it with data, its magnitude, its spectrum, its rotation period. But you can also describe it with wonder, a fragment of another world shaped by forces you can only guess, carrying secrets you may never decode. Oumuamua left you with the image of a cigar-shaped enigma, clean and tailless. 31 Atlas offers you something fuzzier, more alive, less alien in appearance, but perhaps just as profound in meaning. Its shape may not be extraordinary, but its presence is. For in the end, the real shape is not what your telescopes reveal. It is the outline it carves in your imagination. And that outline grows sharper with every night it draws closer. You are living in an age where the cosmos has suddenly begun to speak to you in whispers, and each whisper carries a mystery so vast it shakes your understanding of what the universe truly is. For most of human history, the sky has been a backdrop, distant, silent, unreachable. Stars twinkled, planets wandered, comets flashed across the heavens, and all of it seemed eternal, untouchable. But in recent years, something extraordinary has shifted. The universe has started to send objects across the gulf of interstellar space, drifting into our solar system as if to remind you that Earth is not isolated, not alone, but rather part of a vast galactic flow. The first of these visitors, at least the first one you could identify with certainty, was known as One-Eye Oumuamua. It arrived in 2017 like a messenger from another star, slipping silently past the sun and then back out into the void. It was unlike anything seen before. Long, narrow, elongated like a shard of cosmic debris, tumbling strangely, accelerating in ways that didn't fully align with what gravity alone should dictate. Was it a rock? An iceberg of frozen hydrogen? A fragment of a shattered world? Or, as some dared to whisper, could it have been something crafted, an artifact sent across the stars? You remember the excitement, the speculation, the debates that filled the scientific world. It was exhilarating and unsettling at the same time, for Oumuamua seemed to carry with it the possibility that the universe was even stranger than you imagined. Yet it was fleeting, detected too late to study in depth, moving too fast to capture, leaving behind only a trail of unanswered questions. Now, years later, the cosmos has offered another enigma. It is called 31 Atlas. Officially designated as CSTAS 2019 U7 Atlas, it is another interstellar object, only the third ever identified after Oumuamua and the comet 2I Borisov. But this one is different. This one is massive, more than 100 miles wide, making it the largest interstellar object ever seen drifting into our solar system. The scale alone is staggering. Oumuamua was estimated to be only a few hundred meters long. Borisov, a typical-looking comet, perhaps a few kilometers across. But 31 Atlas is a colossus. Imagine a body larger than some small moons, lumbering across the depths of space, carrying with it the secrets of a star system unimaginably far away. It is, by every measure, a cosmic titan, and its arrival forces you to ask, what is it? Where did it come from, and why now? You are aware that space is not empty. It is filled with drifting remnants of planetary formation, shattered fragments of worlds, icy debris cast adrift when solar systems are young and chaotic. For billions of years, these fragments have traveled the galaxy, crossing the interstellar void, moving from one star's domain to another. Most of the time, they pass unnoticed. But every so often, one comes close enough for Earth to see, close enough for telescopes to lock on, close enough for humanity to whisper again, could this be another Oumuamua? And here lies the intrigue. Because 31 Atlas, despite its size and the data collected so far, refuses to fit neatly into categories. Some aspects suggest it is a comet, its trajectory showing the faintest hints of outgassing, as if frozen ices deep within its body are vaporizing under the sun's heat. Yet, other features don't align so easily. Its motion, its structure, its strange brightness compared to its vast bulk, these leave room for doubt, room for mystery, room for the kind of speculation that once swirled around Oumuamua. You find yourself caught between awe and unease. To witness an object that has journeyed perhaps millions of years through interstellar darkness is to stand at the edge of something profound. This is not merely a rock. It is a survivor of alien creation, a fragment of another star's history, drifting now into your own. It may carry within it the chemical fingerprints of worlds that formed under different suns, with different conditions, different laws of balance. It may tell you what is common across the galaxy and what is rare. And yet there is another layer of wonder, because humanity has only just begun to notice these visitors. For all of recorded history, they have likely passed by unnoticed, slipping in and out while Earth remained blind. Only in the last decade, with powerful wide-field survey telescopes sweeping the skies, have you been able to catch them. It is as though the universe has always been speaking, but only now do you finally have the ears to listen. So here you stand in the early 21st century, watching as a 100-mile-wide colossus crosses the threshold of your solar system. You can't help but ask, is this a random accident, or is it part of a deeper pattern? Are you entering an era when interstellar objects will reveal themselves more frequently, each carrying pieces of the galaxy's larger story? 31 Atlas does not give up its secrets easily. It drifts on, silent and indifferent, massive beyond comprehension. Some scientists believe it is nothing more than an unusually large interstellar comet. Remarkable, yes, but not extraordinary. Others point out that its properties raise the same kinds of puzzles Oumuamua did, puzzles that resist simple explanations. And beneath the surface of these debates lingers the most tantalizing possibility of all, that once again, you may be looking not at nature, but at something made. For now, though, you are left with mystery. Mystery vast as the gulf between stars, mystery carried on a 100-mile slab of ancient ice and rock, mystery that may linger long after 31 Atlas has slipped away into the darkness again. But one thing is certain, you will never see the sky the same way again. For now you know, the universe does not simply sit beyond you. It moves through you, sends emissaries across your path, and challenges you to ask questions that may change your place in the cosmos forever. Word count, 1085. Would you like me to continue directly with Section 3, The Legacy of Interstellar Visitors? You cannot understand the significance of 31 Atlas without first looking back at its predecessors, two visitors that rewrote your understanding of the cosmos. They are the foundation, the stepping stones that prepared you to see this latest arrival not as an isolated oddity, but as part of a larger pattern. The story begins with Oumuamua, discovered in October 2017 by astronomers in Hawaii. At first glance, it seemed like just another asteroid. But quickly, its orbit told a different tale. Its trajectory was hyperbolic, open-ended, foreign. It was moving too fast to be bound to the sun, entering the solar system from above the plane of the planets, slingshotting around the sun and vanishing outward again. There was no doubt, this was not from here. It was interstellar. Its name, appropriately Hawaiian, means a messenger from afar arriving first. And what a messenger it was. Observations revealed something baffling. Its shape appeared elongated, perhaps 10 times longer than it was wide, unlike any asteroid or comet in your solar system. Some models suggested it looked like a cigar. Others argued for a pancake, flat and thin. Worse, it behaved strangely. After its closest approach to the sun, it accelerated slightly, as though pushed by some unseen hand. Normally, comets accelerate because their ice is vaporized, producing jets of gas that act like tiny rockets. But Oumuamua showed no visible tail, no coma, no obvious signs of outgassing. The scientific world wrestled with this. Some proposed exotic natural electrical explanations. Perhaps it was made of hydrogen ice that sublimated invisibly, or a fluffy fragment of a larger body, light enough to be nudged by radiation pressure. Others dared to wonder if it was something more, a fragment of alien technology, perhaps a derelict probe, or even a light sail sent drifting across the galaxy. Though most scientists resisted such speculation, the possibility lodged itself in the public imagination. For the first time, humanity openly asked, what if we have just seen evidence of something not natural? Then, in 2019, came the second visitor, to Borisov. Unlike Oumuamua, this one looked familiar. It had a bright gamma and a toma, a classic comet, the kind you have seen in the night sky before. Its composition confirmed it: ices, dust, organic molecules, all the hallmarks of a comet. The only difference was its origin. It too was on a hyperbolic trajectory, proving it had come from another star system. Borisov reassured you in a way. It suggested that interstellar visitors could indeed be ordinary natural comets, ejected just as your own solar system has ejected countless icy fragments into the galaxy. Together, Oumuamua and Borisov gave you two extremes: one enigmatic, one familiar, one mysterious, one ordinary. And then came 31 Atlas, which seemed to combine aspects of both, yet fit neatly into neither. Its sheer size alone separates it. Where Oumuamua was only a few hundred meters long and Borisov a few kilometers across, 31 Atlas dwarfs them both at over 100 miles in diameter. It is not just a visitor. It is a leviathan, a drifting worldlet, something that could hold its own gravitational sphere if it were much larger. Imagine a mountain range adrift in space, passing silently through your system, unseen until recently, now revealed as an interstellar immigrant. Like Borisov, it shows hints of cometary activity, a faint halo suggesting sublimation. Yet the scale of its bulk makes that activity almost insignificant, like a giant exhaling faint wisps into the dark. And like Oumuamua, its brightness and reflectivity are unusual, not matching exactly what you would expect from a body of its size and composition. Too bright in some respects, too faint in others, it refuses to be pinned down. You realize that each of these objects acts like a chapter in a book you are only now beginning to read. Oumuamua taught you that interstellar fragments can be strange, defying your expectations. Borisov reminded you that they can also be ordinary, natural, predictable. And 31 Atlas now suggests they can be immense, massive remnants of alien systems, crossing your skies with all the patience of eternity. The comparison also raises a deeper question. How many more are there? If 3 have been discovered in less than a decade, that suggests interstellar objects are not rare curiosities, but constant wanderers. The Milky Way may be filled with trillions of them, drifting silently between stars, unseen except when they pass close to a planet with eyes sharp enough to notice. And then you begin to wonder, what if Oumuamua, Borisov, and Atlas are just the beginning? What if you are standing at the dawn of a new era in astronomy, an age when humanity begins to catalog the galaxy not by the light of stars, but by the fragments that drift between them? This realization stirs something within you, both excitement and humility. You live in a universe that does not sit still. It moves, it exchanges, it shares. Every interstellar object is proof that the galaxy is alive with motion, with connection, with stories written in rock and ice. Each one is a time capsule, a relic from a star you may never visit, carrying whispers of alien chemistry and planetary chaos. And though they may pass quickly, they remind you that your solar system is not an island. It is part of a cosmic ocean, and the tides of that ocean reach you whether you are ready or not. And so, as you compare these 3 messengers, Oumuamua, Borisov, and 31 Atlas, You see not just objects, but milestones. The first taught you to question, the second taught you to recognize, and the third now challenges you to imagine what secrets lie within a 100-mile interstellar giant and what other mysteries wait just beyond your sight. When you look at 31 Atlas, the natural question rises almost immediately. Where could something so vast have come from? You are not looking at a pebble tossed across the galaxy. You are staring at a fragment the size of a small world. Its story must begin with violence, with chaos, with forces strong enough to fling a 100-mile-wide body into the emptiness between stars. To understand this, you must step back into the early days of a planetary system, any planetary system, perhaps even your own. Stars are born from collapsing clouds of gas and dust. Around them, disks of debris form, swirling and flattening, coalescing into planets, moons, asteroids, comets. It is a process both delicate and brutal. While some bodies grow into stable worlds, others are tossed about like toys in a storm. Gravitational slingshots, collisions, orbital instabilities all conspire to eject enormous amounts of material. In your own solar system, this happened billions of years ago. The giant planets, Jupiter, Saturn, Uranus, and Neptune, shifted their positions during a period scientists call the Nice model instability. Their gravity flung trillions of icy bodies outward, creating the Kuiper Belt and the distant Oort cloud. But countless others were launched not just to the edges of the solar system, but entirely out of it, sent drifting into the galaxy forever. Now imagine another star system undergoing similar chaos, a system with gas giants larger than Jupiter migrating and disrupting everything around them. In that turbulence, massive objects, some the size of small moons, would be cast out. 31 Atlas could be one of these exiles, banished from its birthplace, carrying the geological scars of its home world. The sheer size of Atlas raises an extraordinary possibility. For an object over 100 miles wide to be ejected, it may not have been a random piece of ice or rock. It could have been the remnant of a shattered planet, a core fragment torn apart by a catastrophic collision. Planetary embryos, the building blocks of planets, often smash into one another during system formation. Sometimes a moon is created, like Earth's. Other times, fragments are flung outward. What if Atlas is one such fragment, a piece of a world that never finished forming, a sliver of alien geology wandering through interstellar night? And consider the timescale. It may have left its star millions, perhaps billions of years ago. Since then, it has traveled silently across light years of emptiness. No atmosphere to erode it, no tectonics to reshape it. Only cosmic rays, micrometeorite impacts, and the freezing chill of deep space. In its silence, it has become an archive, a frozen time capsule from an ancient moment in another system's history. The chemical composition of such a body could be revolutionary. If Atlas formed in the icy outer reaches of its home system, it may contain frozen gases and organics unknown in your solar system. If it formed closer to its sun and was flung outward, it could carry silicates, metals, even exotic isotopes, clues to the processes of planet making under different cosmic conditions. Every atom inside it tells a story of a star you have never seen, a world you will never walk upon, yet one whose history now drifts at the edge of your awareness. The mystery deepens when you think of survival. Interstellar space is harsh, bombarded with radiation, scoured by particles, chilled to near absolute zero. Most objects would erode slowly over millions of years. Yet Atlas, by its sheer mass, has endured. Its surface may be scarred and blackened, but beneath, its interior could remain pristine, untouched since the day it left its sun. In a way, Atlas is a messenger not just across space, but across time, a relic from the dawn of a planetary system long gone. And still, you must confront the other possibility, the unsettling one. What if Atlas did not form naturally at all? What if its sheer size, its reflectivity, its strange brightness are hints of something constructed? You hesitate because the human mind leaps too quickly to the extraordinary. Yet the thought lingers. In your own civilization, you dream of building megastructures, O'Neill cylinders, Dyson spheres, hollowed out asteroids as space arcs. What if another civilization, millions of years ahead, had the same dream? Could Atlas be a derelict fragment of such a vision, a hollowed out world ship wandering abandoned through the galaxy? The rational answer is no. Natural processes are more than capable of creating something like Atlas. But the fact that you cannot dismiss the entirely says something profound about the mystery of interstellar objects. They sit at the threshold between the known and the unknown, between geology and imagination. Every observation that doesn't fit perfectly into expectations opens a doorway into wonder, into speculation, into questions you are not yet ready to answer. And so when you ask where Atlas came from, you are not asking just about one object. You are asking about the history of the galaxy itself. Every star that forms, every planet that collides, every system that shakes itself apart. Each of these contributes fragments to the interstellar dark. Atlas is one of those fragments. To see it is to glimpse the chaos that built the stars and planets. To study it is to touch the history of alien suns. It is humbling. You are reminded that Earth, too, is not immune to this fate. Your solar system has shed its own fragments into the void. Somewhere out there, drifting unseen, are pieces of your world, carrying whispers of your sun, your chemistry, your story. Just as Atlas has come to you, so have your own messengers gone to others. You are not isolated. You are part of the exchange. You are part of the conversation of the galaxy. And in that conversation, Atlas is now speaking. The question is, will you listen? Close your eyes and imagine drifting through space, your ship gliding silently toward the bulk of 31 Atlas. At first, it is just a speck against the void, lost among the background of stars. But as you approach, that speck begins to grow. Slowly, impossibly, it becomes a looming horizon. You realize then what the numbers meant. Over 100 miles across, a mountain adrift in the interstellar dark. If you were standing on its surface, the curvature of Atlas would be imperceptible. Its horizon would feel like that of a small moon. Valleys of frozen ice and jagged cliffs of darkened rock would rise around you, carved by billions of years of cosmic weathering. Craters from ancient impacts would pockmark its skin, each one a scar from a collision during its endless journey through the galaxy. Dust, radiation, and time would have left its surface black, carbon-rich, absorbing nearly all light, making it as dark as fresh asphalt. Yet when sunlight struck it, faint glimmers would flash, a reminder that beneath its charred skin, it may still hide ices, metals, and exotic chemistry from another star. Its mass is staggering to consider. A body 155 kilometers wide could weigh hundreds of trillions of tons. That much matter is not simply a rock, it is a worldlet, a gravitational anchor. On its surface, you would feel a faint tug of gravity, barely noticeable yet present. Loose dust would cling to the ground. Debris from ancient collisions would gather instead of drifting away. In a sense, Atlas carries its own small domain, its own microcosm of order, even as it sails through the chaos of the galaxy. Think of the contrast. Oumuamua was a shard, a splinter. Borisov was a comet, a bright but relatively modest traveler. Atlas is something altogether different. Its presence redefines what you thought interstellar visitors could be. If one object this large can arrive here, how many others drift unseen, too faint to detect? For every giant like Atlas that you find, there could be thousands more slipping by in the dark. The galaxy may be littered with such colossi, relics of planetary systems shattered long ago. Now imagine if such an object ever struck a solar system directly. The consequences would be catastrophic. A collision between a 100-mile body and a planet would release energy beyond comprehension, an apocalypse greater than any extinction Earth has ever known. And yet, just as frightening, Atlas could also carry life's building blocks. If its ices are rich in carbon compounds, if its chemistry includes amino acids, then it may represent not death, but delivery. Perhaps long ago, objects like Atlas seeded young worlds with the materials necessary for life to emerge. Perhaps Earth itself owes part of its biology to fragments from another sun. The scale of Atlas is also a reminder of just how incomplete your view of the universe still is. The fact that such a leviathan was only discovered in 2019, slipping silently through the solar system, shows how blind you remain. Telescopes are powerful, but space is vast, and even giants can hide in the dark. What other colossi pass by unnoticed each year? What messengers have you missed, never knowing they came and went? Scientists know that for every interstellar object you detect, there are countless others you cannot. Your instruments catch only a fraction of the cosmic traffic. Atlas' size makes it visible, but smaller ones slip away unseen. This means that the Milky Way is likely teeming with debris, from pebble-sized fragments to planet-sized giants, all moving silently between the stars. And Atlas is proof that your solar system is not exempt from these encounters. You live at a cosmic crossroads where visitors can appear at any time. Standing in the shadow of Atlas, you would feel both awe and humility. Awe at its immensity, its silence, its endurance across millions of years. Humility at the realization that your world is small, fragile, temporary by comparison. You are used to thinking of Earth as the stage of existence. But here, floating before this interstellar colossus, Earth feels like just another fragment, another piece adrift in the same ocean. And then your mind stretches further. If Atlas is only one, what about others that are even larger? Could planetary cores, hundreds of miles across, be wandering the galaxy as well? Could entire moons, even rogue planets, be slipping past unnoticed? After all, you have already detected rogue planets free-floating between stars, dark and invisible, untethered to any sun. Atlas may simply be the smaller end of a continuum of wanderers, a hint of the cosmic scale of what drifts unseen. What makes Atlas special is not only its mass, but its timing. You are living in the first era of human history where you can see it, track it, name it. For thousands of years, it might have gone unnoticed. But now, with telescopes watching the skies each night, you finally have the ability to witness. To see a colossus drift through your neighborhood is to be reminded that your tools are growing, your vision is sharpening, and your place in the galaxy is expanding. You may never touch Atlas. You may never send a probe to land on its surface. It will slip away, as all interstellar visitors do. But for a brief moment, you can glimpse it, measure it, imagine it. And in that imagining, you begin to realize the galaxy is not only filled with stars, it is filled with fragments of worlds, drifting endlessly, reminders that creation and destruction are universal, that no world is forever, and that the cosmos is alive with movement. Atlas is a colossus, a messenger, a survivor, and in its presence you find yourself small, yet deeply connected, part of a universe larger and more dynamic than you ever dreamed. You find yourself staring into the darkness of space, that endless canvas where silence reigns, and every faint point of light holds a story billions of years in the making. Out there, beyond the safety of Earth's orbit, a quiet mystery is unfolding. Its name is 31 Atlas, a small, inconspicuous designation that might mean nothing to the casual ear. But to you, and to astronomers across the globe, it sparks an uneasy sense of recognition. Because not too long ago, humanity met something like this before. They called it Oumuamua, the scout from another star, and its passage left more questions than answers. Now, once again, a strange traveler drifts into our awareness, whispering of secrets we barely comprehend. You remember the way it felt when Oumuamua was first detected back in 2017. The discovery wasn't just another rock cataloged in the endless list of asteroids and comets. It was something entirely new. Its orbit screamed of interstellar origin, coming from nowhere we could trace, heading off to nowhere we could follow. It was elongated, cigar-shaped, at least that's what the first estimates suggested, and it moved with a kind of grace that didn't quite fit into our models. Even stranger, it accelerated slightly as it left the sun's influence, as though pushed by something unseen. Radiation pressure, outgassing, or something artificial. To this day, the debate hasn't ended. So when whispers of 31 Atlas began to circulate, you couldn't help but feel that same tug of curiosity and unease. Could this be another interstellar interloper, another messenger from the stars, or perhaps from someone among them? The story begins with a telescope, as it often does. The Asteroid Terrestrial Impact Last Alert System, ATLAS, perched atop Hawaiian volcanoes, scanning the skies night after night, searching for threats and wonders alike. Its mission is clear: detect asteroids that could collide with Earth. But sometimes Atlas finds more than danger. Sometimes it finds mystery. In late 2025, astronomers noticed a faint, moving dot against the starfield, one that did not fit neatly into the catalog of known objects. They ran their calculations, plotted its path, and what emerged made hearts race. This object was not born of our sun's embrace. Its trajectory was hyperbolic, too steep, too swift. Like Oumuamua before it, 31 Atlas was a stranger to our solar neighborhood. You lean closer to the thought, trying to feel the weight of it. Interstellar objects are rare, so rare that before Oumuamua, we had never seen one with our own eyes. And yet, in the short span of less than a decade, here is another. The odds seem improbable, but perhaps the cosmos is trying to remind us of something: that our solar system is not a fortress sealed off from the universe, but a crossroad where travelers occasionally pass. The designation 31 Atlas might sound plain, but already whispers of new names float in conversations, some poetic, some cautious. After all, naming has power, and to name a thing is to invite it into human consciousness. Scientists are cautious not to leap ahead of evidence. They remember how speculation around Oumuamua spiraled into debates about alien probes, light sails, and interstellar technology. But at the same time, how can you not wonder? How can you not let your mind drift into that forbidden territory, imagining that somewhere out there, another intelligence may have noticed our sun as just one among billions and decided to send a messenger? For now, though, all you have is data: its orbit, its brightness, its trajectory, cold numbers glowing on a screen. But numbers have voices if you know how to listen. They whisper of origins outside the Oort cloud, of a journey that began perhaps millions of years ago when this object was nudged by the gravity of some distant star, cast adrift through the endless dark. Imagine that: a shard of matter, older than human civilization, older even than Earth itself in its current form, wandering between suns until chance brought it here, into your awareness. You feel the tension that scientists feel now, the pull between skepticism and awe. Could 31 Atlas simply be another comet, icy and unremarkable, its interstellar origin a trick of incomplete data? Perhaps. But what if it isn't? What if it carries with it the same enigma that Oumuamua did, or more? Each observation sharpens the picture, but also deepens the mystery. Its shape is uncertain, its composition unknown, its brightness curve puzzling. Already the debates begin. Already the community divides between those who call for caution and those who whisper, "Could it be?" You imagine telescopes across the world swinging toward it, time booked frantically, astronomers racing against the inevitable, because that is the cruel truth about these visitors. They do not linger. They streak through our system like ghosts, visible only for a fleeting season before vanishing forever into the black. Every second counts. Every photon of light collected may be the last clue we ever gain. And so the chase begins. As you watch this story unfold, you feel a strange intimacy with 31 Atlas. You will never touch it, never stand upon it, never hold a fragment of it in your hand. And yet, in studying it, you brush against something larger than yourself. The reminder that the cosmos is alive with wanderers, that the universe is not a static map, but a living ocean, where ships of stone and ice drift endlessly between stars. One of them has come to your shores again, knocking at the edge of human imagination. And so you lean forward, you listen, you prepare yourself to follow 31 Atlas across the sky, across the debates, across the whispers of what it might mean. Because deep inside, you know this is more than science. This is a story about connection, about whether you are truly alone or whether the universe has ways of speaking through rocks and ice, through silence and acceleration, through shapes that defy explanation. The mystery has begun. You cannot think about 31 Atlas without the ghost of Oumuamua hovering close by. It was the first, the pioneer, the object that cracked open the door of possibility and forced humanity to stare into the void with new eyes. Before it, interstellar travelers were theoretical, mathematical guesses about what should eventually drift into our cosmic backyard. But when it came, it was nothing like anyone expected. And that shock still lingers. It colors every observation of this new visitor, every cautious word written in the margins of research papers, every sleepless night astronomers spend poring over light curves and orbital models. You remember the day Oumuamua's discovery rippled across the news in 2017. It was not simply an asteroid, nor did it behave exactly like a comet. It had no obvious tail, no bright halo of gas. Instead, it spun like a cosmic baton, its light dimming and brightening in a rhythm that suggested a shape unlike anything seen before. Some said it resembled a cigar, long and thin. Others argued for a flat, pancake-like geometry. The truth? No one could say with certainty. And then came the acceleration, the subtle, impossible push that nudged it as it exited the solar system. Was it natural outgassing, a jet of vapor invisible to our instruments? Or was it something designed, something alien in origin? The debate raged, and in some corners of science, it still smolders. Books were written, headlines exploded, whispers of extraterrestrial technology crept into mainstream conversation. You felt it then, that electric mix of wonder and fear, the kind of feeling that makes your chest tighten as though you've glimpsed something forbidden. And now, with 31 Atlas on the stage, those echoes grow louder. The human mind cannot help but compare, cannot help but ask, is this the sequel to that mystery, or is it something wholly different? The first thing you realize is that frequency itself is strange. How could two interstellar objects reveal themselves within a span of years, after billions of years without a single confirmed detection? Is the galaxy sending us reminders, one after another, that the interstellar medium is not empty? Or is it merely that our tools, sharpened by technology, now finally catch what always passed unnoticed? Telescopes like Atlas, Pan-STARRS, and instruments orbiting above Earth's atmosphere see deeper, faster, more precisely than ever before. Perhaps these visitors have always come, and you simply never noticed until now. That thought sends a chill through you. The possibility that interstellar travelers may have crossed Earth's path countless times, silently drifting past, unobserved and unstudied, each one carrying secrets lost forever. But there's more. Oumuamua carried the allure of the unknown, partly because it was fleeting. By the time astronomers realized what they were dealing with, it was already racing away, dimming with each passing day. Opportunities slipped like sand through fingers. Telescopes strained, but the resolution was never enough. You were left with shadows and guesses. 31 Atlas, however, offers another chance. The chase is alive again. This time you wonder, can humanity be quicker, sharper, more prepared? Can you catch this one before it slips away into eternal night? As you trace this thought, you feel the emotional weight pressing in. Because deep down, Oumuamua left scars on the scientific imagination. It was the reminder of how fragile human curiosity can be, how easily answers slip through when the universe decides to be stingy. Astronomers fought over theories like shipwrecked sailors fighting over scraps of driftwood. Some clung to the comet theory, outgassing, natural acceleration. Others whispered of solar sails, alien probes, fragments of lost civilizations. None could prove their case. The object was gone, and with it, certainty. Now, 31 Atlas hovers in that same twilight of ambiguity. Already, measurements of its orbit reveal the hyperbolic curve of an interstellar origin. Already, questions pile up faster than answers. Will it accelerate strangely, like Oumuamua? Will it spin in a rhythm that defies easy classification? Will it show a tail of vapor or remain stubbornly barren, neither comet nor asteroid, but something we don't yet have language for? Every possibility feels alive. Every scenario, from the mundane to the extraordinary, hovers in your imagination, and you sense something else, a deeper, more human reaction. Oumuamua reminded humanity of its smallness. It reminded you that even in an age of satellites and Mars rovers, the universe can still surprise you with something utterly alien in form and behavior. That wound to certainty never healed. And so, when 31 Atlas appears, the scar tissue tingles again. You cannot help but feel exposed, humbled, vulnerable under the vast dome of the cosmos. Yet there is also hope. This time, astronomers prepare more quickly. Networks of telescopes coordinate, data is shared in real time, instruments across Earth and in orbit pivot to watch. You can almost hear the hum of urgency in the air. A global chorus of scientists straining to glimpse the truth before it is gone. This is more than curiosity now. It feels like redemption, a second chance to decode the message the universe is sending. And so you look up, your mind caught between memory and anticipation. Oumuamua was the whisper that stirred you from slumber. 31 Atlas may be the continuation of that whisper, or perhaps the shout that finally forces you to listen. Whatever it is, you know one thing. History is unfolding again, right above your head, in the quiet shimmer of stars and the faint track of a stranger that does not belong here. The echoes of Oumuamua are alive in every calculation, every observation, every heartbeat of this pursuit. The stage is set. The actors are watching. The second interstellar mystery has arrived.